I said 2 cosine.
All right, guys, so make sure that you are learning these identities. Most of you are in pretty good shape. The errors are small ones, but some people clearly have not spent time. If you are struggling, I am confident it is because you have not taken my advice and made flashcards. If you aren't getting 20 out of 20s or at least 18 out of 20s, guys, think about it. If you're getting 90% of them right on a quiz, you're like, oh, that's cool, 18 out of 20. Well, that's 90% of the identities. On the test, that means at best you're going to get 90%. Then you're going to have to apply them. So the ones that you don't remember, you're guaranteed to miss all of that problem. And even the ones you remember, you might apply incorrectly. Now you're putting yourself in even worse shape. Are you following me? Because like even if you get 90% of that 90%, now you're looking at an 81. And if it's worse if you like only know 80% of the identities, and then you're getting 80% of the 80% right in the application. Now you're looking at a 64. You have to know these trig identities backwards and forwards. You can't let that be the part that drops you down. You got to let that be the part that boosts your grade. Are you with me? Now I'm dropping one. Hopefully it wasn't that first one because that was probably the easiest one because there's less identities. But I'm dropping one of those 4. But that's still, hopefully you'll keep all 4 of them. I mean, I'm not going to drop it if it's a 20 out of 20 or if it's better than your average. I'll keep it because that's an 80 out of 80. That's like getting a 100% on an 80-point test, right? That's going to boost your average a little bit, especially if you tend to struggle a little bit from time to time in here. Yeah.
So tomorrow's quiz is back on the half points.
Tomorrow, yeah, I'll add half angles to that, and we're going to be using half angles today, but I didn't put both of them on there because I just wanted you to have a little bit of baby steps as you're walking through these quizzes. So you'll add to those the half angle identities. Now the half angle identities, there are half angle sine, half angle cosine, half angle tangent. And don't confuse half angle with half of a trig function. It's not like sine of theta divided by 2. It's the sine of theta over 2. Okay, so you're having the angle. And we'll talk about why we're going to use that or why we need that. So if you want to jump with me to the book and check out page 53, we're actually going to jump straight into the half angle identities. Now, the half angle identities, if you don't know those yet, here they are. They are the sine of half of an angle. And this part's really important right here. You're going to write on your quiz tomorrow, too. I'll write them over here under each one. The half angle identity for sine, when on your quiz tomorrow, you're going to write either plus or minus the square root of, and then you end up getting 1 minus the cosine of not this angle, but the angle that I divide by 2 that gives me that angle. So this allows me to not have to use 22.5 anymore. You'll see this in a second. It allows me to use that one there. And hopefully that one that I choose will be on the unit circle and I can actually simplify it. But when you're doing this simplification, it's not like when you solve it. You know how when you solve an equation like this, you get x equals plus or minus 2, and both 2 and negative 2 work? It's not like that here. This is you choose. The answer you get will either be positive or it will be negative, but it's not going to be both. We're going to write both on our identity because the identity says, hey, depending on your angle, you're going to get a plus or a minus. But like on this problem, you're going to have to pick. Is it the plus or is it the minus? And it's not hard to pick. It's just easy to forget to pick. Okay? Now, on the cosine of the 105, looks almost like that. All right? It's the cosine of the half angle. Looks almost like this. The only difference is it's 1 plus cosine of the theta over 2. And I won't be using 105. That's not in the unit circle. I'll be using the angle that when I divide by 2 gives me 105. And you'll see that in a second. So when I rewrite this 105 as a half of an angle, I'll use that theta there, and that'll allow me to simplify. And again, it's not plus and minus, it's you choose. Like, I'll go ahead and talk about it right now. if you were to take the sine of an angle like 22.5, which is clearly in the first quadrant, would your value be positive or negative?
Positive.
And choose the plus. On this one, if you take a cosine of an angle that is clearly in the second quadrant, right? The second quadrant, would it be positive or negative there?
Negative.
Negative. Then you're going to pick the negative. So you just choose it. So most people know how to choose it. Problem is people forget to choose it. They just accidentally put the plus or minus and leave it there. But you got to remember, on the identity quiz tomorrow, write the identity out. But in the future, you got to decide is it plus or minus. Now for tangent, the easiest way to remember tangent is the crappiest identity. There's 3 identities. The easiest way is this one. The tangent of half of the angle, since tangent is just sine over cosine, what would happen if I took this sine of half angle and put it over that cosine of half angle? What do you think would happen? The 2's would cancel, wouldn't they? And you'd have that part on the top, and you'd have that part on the bottom, which you divided, right? Well, that's the half angle identity for tangent. It stinks.
But how can you count the 2 when each one's under a radical?
Well, you're canceling a root 2. Like, look. You have that and that. And you're dividing. And you learned when you divide a root A divided by a root B, you get a root AB. So technically this root is really over all of it. And then to divide by a fraction, you multiply by the reciprocal, that cancels, and you're left with this over this. But don't ever use this one if you have better options. Here's the reasons why I will never use this unless I have no other option. And you will probably see that. If I have the choice and I choose to use this, more than likely, I mean, think about what are your possible values when you take the cosine of something. You might get a root 3 over 2. You might get a square root of 2 over 2. And now you're stuck with a square root inside of a square root, and you have a fraction of the top and the bottom. That's terrible. You have so much simplifying you need to do, it's going to look awful. Now, through some math that's hard to explain without getting into identities that we don't need in Algebra 2, it's kind of weird here that we're going to use identities that you prove by using other identities that aren't Algebra 2 identities, but to get these other proofs, which are these 2, and these are other options, you can use 1 minus the cosine of the theta over a sine of a theta, or you can also use sine of a theta over 1 plus the cosine of the theta. And the proofs to those are a little bit uglier, but I like this one. And the reason I like that one is I don't have to decide if it's plus or minus. If it's positive, it'll end up positive. If it's negative, it'll end up negative. Just does it itself. Also, I have a monomial in the denominator. Like I'm going to get like a root 3 over 2 down there. But over here, I might get a 1 plus a root 3 over 2. Are you with me? And rationalizing a binomial is more work because you got to use a conjugate than rationalizing a single squared 3 or something like that. So this right here, excuse me, is almost always my happy place. Now there are times when I'll use that, but we don't even need to talk about it right now. Like for instance, let's just say I'm doing a half angle cotangent. Well, I'm not learning those identities. So what's the well, how could I use this to do a cotangent?
Flip it.
Flip them. Well, I kind of like this one for the cotangent then. If I'm going to flip it, if it's a cotangent of a half angle, why not just flip that one and then I'm back to having a monomial on the bottom? Are you with me? But for a half angle tangent, that's where I'm going. Okay, now, so today we're going to walk through these half angle tangents. I'm going to show you there's going to be a new little simplifying thing. It's not new, but I'm going to remind you about it, and you're going to use it 5 or 6 times today. So don't shy away from this. It's a really nice way to simplify, but let's think about this. So I have a question for you. Like yesterday, when I asked you to do something like cosine of 105, and yesterday I said, are there any angles that you could add or subtract that are located on your unit circle that would give me that? Yesterday you might say, oh yeah, 45 and 60 would give me that. And you rewrote that as a cosine of 45 plus 60. And you could do that today, again, to simplify this, with one exception. It says use half angles. So on a half angle identity, you're asking yourself this: are there any angles that I could divide by, any angles on the unit circle, that when I divide them by 2, I get that? 45. So that is the same thing as sine of 45 over 2. And you can see that because 22.5 and 45 halves are both 22.5. Now let me show you where people mess up. People hear me say that, and then they go home and they go, man, if I just double 22.5, I get 45. So why don't I just say sine of 2 times 22.5 is 45? Sweet. Well, why can't I just double it? Because you can't just wander around doubling stuff, right? If we could, go into the main. So this is a different angle than that. But is 45 halves a different angle? No, it's the same thing. It's just rewritten as a fraction. Are y'all with me on that? Okay, so here's why this is helpful now. I no longer have to deal with 22.5 anymore. I can deal with 45. So the half angle identity says, oh, whatever you're having, I'm having the 45, you can use that angle in your formula. So now I can come over here and go, all right, well, my half angle formula is 1 minus the cosine of the angle that I'm having, which is 45, divided by 2. And then you decide, is it plus or minus? And I think we already said sine of 22.5 would be plus, so I leave it plus. And you don't have to put the plus in there, it's understood. But you would have to put the minus. Now, can I stop here? No. So what would be the first thing you do to simplify this? Okay, so I'm going to change that cosine of 45 to what? I wish. Root 2 over 2. Okay, now I'm here. Now, on this, I can't leave it like this. This is all kinds of awfulness. So I have a fraction inside of another fraction. Now, you can do this by finding a common denominator with 1, making it 2 over 2, subtracting that, and then dividing by this other 2 is multiplying by a half. You can do that, but look how easy this little trick is. If you have a fraction which has another fraction in it, then I want you to look at all 3 of these numbers, the 1, the root 2 over 2, and the 2. Look at all 3 numbers and tell me what is the common denominator of all 3 of those. 2. Then multiply the top, you're inside right here, multiply the top and the bottom by 2. Am I allowed to do that? Yeah, because 2 over 2 is 1. And look what happens. When I distribute that 2 in, I'm still under the radical here. I get 2 times 1 is 2. 2 times the fraction, the 2's cancel, and I'm left with minus root 2. And on the bottom, I get a 4. Now, I could probably simplify this a lot more, but we're okay with just cleaning up the bottom now. So I'm going to leave the top part as a square root of 2 minus root 2 underneath the radical. But what's the square root of this 4 on the bottom? A regular 2. Now, what you have to make sure you're doing when you're writing everything, you have to really make sure that up here in these first 2 steps in purple, that this square root goes all the way down and covers up that 2 right there, all the way down the bottom. But here, once you do the root 4, now you got to make sure the square root's just on the top. Y'all with me? And if you type that in your calculator correctly, you'll get the same decimal you do if you type in sine of 22.5. All right, that's half angle sine in action. Let's try cosine.
So it's okay to leave the radical inside the radical?
That's, yes, it's possible you can simplify this more. Sometimes you can, sometimes it gets really ugly, but we're not going to. All right, now what about cosine of 105?
You're recording, right?
Yes.
Just sorry.
Yeah, so it's cosine of 105. I got to be honest with you. If I was doing this on a test, I would not use a half angle. I wouldn't, for a couple reasons. What he just said about the square root being inside of a square root, there is usually a better way to write it. And the answer that I get from this is going to have a square root inside of a square root. And there's a better way to write it. And that better way is what I would have gotten had I used the alpha plus beta. So when I am doing a cosine or a sine, and I can use an alpha plus beta, I am going to do it. Or maybe an alpha minus beta. I am going to do it. But on a tangent, you'll see that half angle tangent is so much better than the alpha minus beta. Do you remember me doing the alpha plus beta, alpha minus beta tomorrow? And I made a point to say, all right, I'm going to mention this to you. And I'm going to say, remember how ugly this was? And it was like 7 or 8 or 9 steps. I forget, but it took us a whole bunch. Watch how quickly we're able to do this. Because I could do this with a tangent of 45 minus 30. And it would take me 7 to 9 steps of terrible simplifying. But watch how quickly it is when I do a half angle in a couple seconds. Coming back to this. So ask yourself, if I have to use a half angle, is there an angle on your unit circle that when you have it, gives me 105? 210. So 210 over 2 is the same thing as 105. And now I don't have to worry about 105. I can use 210. 210 is on my unit circle. Awesome. So what's the half angle identity for cosine? Tell me. Negative. Why negative? Because you already know that that would have been a negative. Now, by the way, don't do this. Every now and then somebody will look at this and go, all right, I'm looking at 210. 210 is in the third quadrant. No, don't look at the number over 2. Look at the whole number. The whole thing is 105. 105 is in the second. Cosine's negative in the second. Use a negative. It's that I'm looking at right here. Okay? Now, my identity tells me to do what? 1 plus the cosine of 210 divided by 2. Now that I've used that identity, let's clean it up. So I've got negative. That's going to continue to remain out there. What is the cosine of 210? Think about it. 180. 210's down a little bit. We want the x value there. Over a lot. So negative square root of 3 over 2. And then bring over the 2 on the bottom. And just like I did before, is there a common denominator, since I have a fraction and a fraction, between that, and that? So I'm going to multiply the top of the fraction by a 2 and the bottom by a 2. I'm going to distribute it in there. And that gives me 2. Plus and minus gives me minus. 2's cancel, gives me root 3 over a regular 4. And that simplifies to what?
The top stuff over 2.
The top stuff over a regular 2. And you know what I would have gotten had I done the alpha plus beta identity? I would have gotten this, I think. Let me double check. I would have gotten, let me make sure about this, negative root 6 plus 2. Yes, I would have gotten that. Does that look like this? No. So on a Vestavia test or at a state tournament, it's possible you get one of these. And when you get one and you look at it and you're like, you know what, I could have done a half angle for that. I could have done an alpha plus beta for that. You got to look down at your answers. And if your answers have square roots inside of square roots, then it's probably one of the half angle ones. Use the half angle identity. If the answer looks like more like that, then use the alpha plus beta. Because if I type that in my calculator and I type that in my calculator, I get exactly the same number. That's what this would have simplified to. And I can show you how to do that, but that's really not part of this lesson. If you really want to know how to go from there to there, it's not difficult. You can figure it out. I can show you. Just takes a little bit. It's kind of like, remember when I took the square root of an imaginary number? You would set it equal to a plus bi. Well, if I'm taking the square root of a number like that, you set it equal to x plus y root 3. And you do it, we probably did something like that, and you do it exactly the same way. But I'm not going to ask you to do that on this test. So if you gave me that as an answer or that as an answer, you would be correct. The only reason on this part why that has to be the answer is because I told you to use a half angle. All right, now we get to tangent. And remember how awful it was when we did the alpha plus betas, right? 7, 8 steps of pain and misery. Watch how easy this one is. that, is there an angle on the unit circle that you can have and get 15? 30. So I'm going to rewrite this as tangent of 30 halves. So using my happy identity, the one that doesn't have the radical, all I have to do is do what here? 1 minus cosine of what? 30 over sine of 30. And look how easy this is going to clean up. What's cosine at 30? Square root of 3 over 2. So I get 1 minus square root of 3 over 2. What's the sine at 30? 1/2. Everybody with me? And what do you do when you have a fraction inside of a fraction? Multiply by that common denominator. And what does that leave me with? 2 minus root 3 over 1. Done. 1, 2, and I'm done. As opposed to 7 steps of misery and suffering. Now it's possible it might not be that easy, because if I got a root 3 over 2 on the bottom and a 1/2 on the top, I'm still going to have that root 3 there. But it's pretty easy to clean up a root 3, right? Multiply by root 3 over 3 and you're done. So even if that had a square root or something on the bottom, it's still one extra step and pretty simple. Now, if you pick this one, more pain and suffering. If you pick this one, a little bit more pain and suffering. So that's the best one to pick when you're dealing with half angle tangent, even when you have the option of doing alpha plus betas. Again, half angles were great for tangents, not as great for these, but if you got to use them, you got to use them. All right? Now, for those of you with double angle, if you're like, well, when am I ever going to use a double angle in a situation like this? Well, you're probably not, because look, think about it. Tangent of 60. Is there an angle on your unit circle that you could double and get 60?
Yeah.
Oh, 30. I could use a double angle tangent here, couldn't I? But why on earth would you want to do that when I already know tangent of 60 is root 3? Done. Why would I want to pull out a double angle identity? Whenever I can rewrite it as a double, think about it. Every angle that's on your unit circle right now, if you double it, isn't it already on your unit circle? Well, then you're never going to use a double angle like this. The only way you're ever going to use a double angle would be a problem like this. What if I said 2 sine of 15 cosine of 15? Does that look familiar to you? That's a double angle sine, right? So if 2 sine theta cosine theta is sine of 2 theta, and your theta is 15, then all you have to do is what? Plug a 15 in. Oh, and that gives you sine of 30. Oh, and that gives you 1/2. That's when you would use a double angle, like when I give you the right side of the equation and you're coming back to the left side. But when I give you the left side and you're using the right side of the identity, at least the way I set them up, that's when you're going to have to apply this half angle stuff. All right, let's jump down to this next one. Go with me? I don't know what it is about this lesson that makes everyone really quiet. Fourth period is like, it's like a morgue in here. Okay, look at number 2. What am I giving you on number 2? It might smell a little bit like what we did yesterday. What am I giving you? Right here. But what does that mean when I'm giving you the answer to cosine? I'm giving the cosine of an angle is some ratio, but what does that mean?
You're giving you the sides.
I'm giving you a couple sides of this triangle that has an angle that's theta, right? And what is that other part telling me? Where the angle could be. And it's even nicer in this one because instead of going from like 90 to 270 or something like that, I said between 270 and 360. So I'm just telling you it's in what? Fourth quadrant. And normally that's going to be really important to you because that's going to change the sign of that other value more than likely. So don't make this mistake. Don't look at this and go, oh, theta. Cosine of theta is 4/7, blah, blah. Don't do that. It's important that you go, wait, this theta is here. So this is not a first quadrant looking angle. This is a fourth quadrant looking angle, isn't it? It's between 270 and 360. It's down here. And if I label my 4 and my 7 here, what's the difference between that and that? Yeah, this would have been a root 33, and this is a negative root 33. And in much of the work we do, that negative will impact your work. It doesn't happen to impact it here, because it just happens to be a double angle cosine. And if you think of your formulas for double angle cosine, what am I doing with all the trig functions in those? Squaring them. And squaring that negative is going to make it positive. So it didn't really hurt you, that mistake here, but it more than likely will hurt you on a lot of problems. Okay? So now that I got my picture, and you tell me in a second if you even needed that picture on this problem, how do I let that picture of theta help me with a 2 theta? Because 2 theta is twice as big as that angle. Can you draw and label the triangle that has an angle twice as big? Does twice as big mean this side is twice as much? No. It's actually more than twice as much. Sorry. So you don't know anything about 2 theta. Man, if only there was a way to change a 2 theta to a single theta. And there is. So what are your identities here? I could use cosine squared theta minus sine squared theta. I could use 1 minus 2 sine squared theta. Or I could use 2 cosine squared theta minus 1. And if you're really on your game, you'll pick this one, because the only thing I need to know here is cosine theta, and that was given to me. If I pick this one or this one, I'm going to have to find sine theta from the triangle. Now, I already found this triangle, and I found the root 33 doing Pythagorean theorem. But if I was on my game and noticed that and really knew my identities, I would go, oh, I already know the cosine of the angle. So I'm going to find the cosine of the angle, put it in here, square it, and subtract 1. So all I really had to do here was put that 4/7 in and call it a day. Well, I got to clean it up, right? So that would give me 2 times a 16/49, which is 32/49 minus 49/49 is negative 17/49. But you'll get the same thing no matter which identity you use. Are y'all with me? But more than likely, I got to be honest with you, more than likely you're going to have to draw the triangle. Because I don't have to give you cosine here. I could have given you cotangent of the angle is something. It's 4 over root 33 or something like that. All right, what about this one? 3 and 4. I gave you this picture. Number 3, I want you to find the tangent of half that angle. Now, can I come in here and split this angle in half and say, okay, if that's theta, then this is half of theta, and that would just be a 3. Is that good logic?
No.
No. For those of you who are looking at that and going, no, why isn't it? If this was the angle, if this was the triangle like this, right, if that was a right angle, then yes, and that was 6, that would be 3 and 3. But you can see when I move this up right here, if I roll that over, slide it over, this part is longer now, isn't it? So I can't do it. So how do I change and not use theta over 2? Go to your formulas. Which one do you like?
The one with sine on the bottom, so 1 minus cosine theta.
That's the one I like. Now, to do that, I'm going to have to know something else. What is it?
The other side.
The hypotenuse, right? So I got to suck it up and go, all right, if that's my hypotenuse squared, or r squared, whatever you want to use, is 6 squared plus 11 squared. So h is the root of what? What's 121 and 36? 157? And you're like, oh, wait a minute. That's an offensive radical. Okay, watch how easy it is to deal with this radical. So yes, that is root 157. But watch how easy it's going to be for you to clean it up, even when it looks like it's not going to be easy. So check it out. 1 minus. What's the cosine of that angle? 157. Do not rationalize it for now. Now, what is the common denominator of all three parts of this fraction within the fraction? Root 157. So when I multiply the top and the bottom by root 157, and I multiply it through, distribute it in, what do I end up getting?
Root 157 minus 11 over 6.
So on the top, I get root 157 times 1 is that. This, it cancels, gives me a minus 11, and here it cancels and leaves me a 6, and I never even had to rationalize. So even when you think it's ugly, it's probably not going to end up being that ugly. I mean, that's not pretty, but it's not terrible. Right? Now what about double angle? Now double angles, sadly, are kind of like the alpha plus betas. Sometimes they can get a little nasty because they come from the alpha plus betas. All right, remember we talked about that yesterday? So on this one, it's not going to be as bad as you think, but it's going to be a little simplifying you're going to have to deal with. So how do you get a 2 theta out of there so you can use this theta?
2 tan theta.
Okay, so 2 tan theta
1 minus tan squared.
over 1 minus tan squared theta. And remember, tan squared theta just means tan theta quantity squared. So do I know the tangent of this? Well, to do that, I didn't even need to know the hypotenuse, did I? So what's the tangent? So here we go, 2 times the 6/11ths, and on the bottom, 1 minus the 6/11ths squared. Now before you get squirrely and multiply the top and the bottom by 11, make sure you realize that the common denominator of all of those fractions is not 11. It's really what? 121. So I'm going to clean it up a step. 12/11ths on the top, 1 minus 36 over 121. Then I'm going to decide what to multiply by. So yeah, I'm going to multiply the top and the bottom by 121. And what does that give me on the top? 11 times 12 is 132. Good. And what's that give me on the bottom? 121 minus 36. So my net result is 132 and what, 85? And then if that simplifies any, knock yourself out, but I don't think it does. Unless 7. I think it does. 17, does that go into 1? No. 1, 2. No, I don't think so. Y'all with me? Feeling okay so far? Does this feel a lot different from yesterday other than just different formulas? I hope it kind of feels the same. We're just using different formulas here. And if you think about back to that problem we did yesterday where I gave you a little bit about alpha and a little bit about beta, you had to draw 2 triangles, right? Because you had an alpha and a beta. And all of these, you just have one angle. So usually you're going to have to draw 1 triangle at best. Sometimes they give it to you. Sometimes they don't, but they give you information about it so you can draw it. So anyway, I'm going to jump because of time. I want to make sure I get finished down to the bottom, 6, A, B, and C. So check out 6A. First thing you got to do is look at it and go, huh, does that look familiar?
Yeah, that's cosines.
That's a cosine half angle, isn't it? But it's a little different. So if you can't, like some of you are able to look at this and go, oh, that's a cosine of a half angle. But my angle's not theta. It's what? 6x. Swing a 6x in its place. Some of you might need a little bit more help. Some of you might need to go, oh, I think that this is a cosine of a half angle. Well, if that's the case, write out your formula. And once you write it out and go, all right, what changed here? Clearly, my theta was replaced with a 6x. Well, then do the same thing here. Replace your theta with a 6x. And then what's cosine of 6x over 2? So what did I just learn?
That's just half of the.
This is not a double angle identity. This is a triple angle identity. Now, this is one of those that we don't even memorize. I think on your worksheet, there is a triple angle identity for cosine. It looks different than this. There's all kinds of them. So we don't bother memorizing this thing because we have an identity that can help us out. But this is actually a triple angle identity, which means, well, which doesn't mean a ton, but whatever. What about this next one?
Double.
Looks a lot like a double angle tangent. Now the double angle tangent would be tangent of 2 times theta, right? But clearly there's not a theta there, there's a what? 22.5. Well, then replace the theta here with 22.5, which now gives you what? 45. And what's tangent of 45?
Wait.
Why? Because the y's and the x's are the same. Root 2 over 2 over root 2 over 2. And, or because you memorized that any tangent that has a 5, like a 45, a 135, a 225, and a 315, they're all either 1 or -1, depending on the quadrants. Right? What about this next one? Now, this next one's going to require 2 steps, but initially, you might not see that at first. Initially, does it look like anything? 2 cosine squared theta minus 1. So it looks like a cosine of 2 theta identity. But what's the theta? 7.5. So really, what is this really? This is a cosine of 15 degrees. Now, if that had been cosine of 14, I'd have stopped, because I can't do anything with 14. But can I with 15?
Yes, you can double
45
it.
minus 30.
Whoa,
Oh, wait, no, you can't double it.
I'd be going to the bank if I doubled it.
30 over 2.
It's not on the unit circle.
It's not on the unit circle, but are there any 2 angles or 1 angle on the unit circle? Are there any 2 that you could add or subtract to give me that? Is there any 1 that I could divide by 2 to give me that?
45 minus 30.
Okay, now, what do you like better with cosine? 45 minus 30, like an addition subtraction, or a 30 over 2 half angle?
45 minus 30.
Yeah, the alpha plus betas work better for sine and cosine. They give you better answers. Okay, so I'm going to change that to a cosine of 45 minus 30. And what is that identity? Cosine first, cosine second, plus sine first, sine second. And then all you have left is a unit circle barrage at this point. Cosine of root 45 is root 2 over 2. Cosine of 30, root 3 over 2. Sine of 45, root 2 over 2. Sine of 30, a half. So in the end, a root 6 over 4 plus a root 2 over 4, which is a root 6 plus root 2 over 4.
Why does that come up so much? Root 6 and root 2 over all over 4.
Because you're constantly doing stuff with 30s and 60s
And root 2 over 2.
Yeah, root
right. It's because you're using the same values.
Unit circle is very.
But hey, keep in mind, if I did a half angle right here and did a cosine of 30 over 2, my answer would be the same, but it wouldn't look like that. And that would be okay on a test. Just wouldn't be okay on a multiple choice test.
So, like, on the test, are you going to tell us which ones to use? Or are you just
Probably not. There might be one that I say use this because I want you to show me a particular math or maybe make it easier for me to grade. But, oh yeah, and I'll take one more day if you want to turn in your, you want to give me your course request. After that, you're on your own, which is fine. But it says you can give it to me, Mr. Butler, the junior counselor. But at this point, I'm turning these in after school today or tomorrow morning early. It's no big deal to me. I'm just saying, it's a long journey to the other end of Homewood to turn these in. I make it there maybe once or twice a week. Helmer's came up to see me the other day. He's like, I'm out of breath.
Oh, that's what we say whenever we come up the stairs. Yeah.
It's a hike. It is.
You would think we've gotten used to it, we just
I come up here usually once, and then I leave.
Yeah.
Once or twice a week, I'll go down to check my box or whatever. But
Last year, I had like first period was first period was bad all the way around 4 a.m. I had several classes like right at the end of the freshman hall. It was the book.
Yeah.
It was for homework.
yeah, if you had band and you had Hummers, y'all were zigzagging back and forth like all day long. Like if you had to go freshman hall to band, to freshman hall to Helmers, to freshman hall.
Okay, first semester, I would come up here, like I would, because my class was over there, so I'd come from Miss Smith's room to up here to all the way down to like the 3rd floor right beside where the trainer is. like beside the new front office. And then I would have to come upstairs to do a news class. And then I'd go across the library to my other class.
Wait till you
And
go
I'd
to college.
downstairs to the gym.
You go to college, it's like, oh, I gotta go to blah, and then I gotta go to blah, and it'll be a 25-minute walk, depending on where you are. I mean, if you go to Auburn and you live in the quad, well, you're right there next to everything. But like if you live in the hill or you live on the edge of campus or whatever, and you don't have a bike, I mean, you'll be hiking, which is good, lets you eat more pizza. The freshman 15 is a real thing.
Oh, really?
Dude, I've had friends of mine, even students of mine, that will leave here looking all fit and svelte. And then at the end of the first year, you're like, oh my gosh, they've gained 60 pounds.
She just said sophomore 15 to me.
Oh, it could be any.
Yeah, that's
But if you're, like, for instance, at Auburn, dudes used to never live in the dorms because they were terrible. And now there are some dorms, actually, you can live there, it's okay. But back then, dudes would live in their apartments so they could buy their own food, make their own food. They could try to eat healthy, although they probably didn't. But girls were stuck eating dorm food night and day. And if you're eating dorm food night and day, plus there's always like a Chick-fil-A right there. You start eating that crap night and day, man, and it is really easy. And you're not like playing sports anymore, maybe. Really easy to find some new friends,
You said
you know?
All right, have a good day.
All right, man, you too.